Hello friends, welcome to my channel. Let's have a look at problem 1979. Find greatest common divisor of array. So this video is a follow-up for that of Leetcode problem 2447. So in that problem, we are required to find the number of subarrays with common GCD equals to a given integer k. So this problem actually can be regarded as some sort of prerequisite for that problem. So now, after visiting that problem, let's look at this one. So this problem actually is an easy problem. So here, let's look at the statement. Given an integer array called nums, so return the GCD of the smallest number and largest number in nums. So this is the definition of GCD, which is actually an elementary concept in arithmetics. So here are three examples. Let's look at one of them. So in example 1, so the smallest one is 2 and the largest one is 10. So the GCD is 2, so we return 2. So in the third one, so the elements are unique as a set, so the return is the unique element, that is 3. So here the length of nums is bounded below by 2 and bounded above by 1000. So here actually for this problem to be valid, so the length can be 1, right? So in that case, the min and max coincides. So here the nums I element is in between 1 and 1000. So with that said, so we are ready to do the analysis. So here in this problem, so our goal is to implement a function from scratch for computing GCDs of two integers. So for those with some math background, here is a proof of the thing what we are going to use. So this is the thing we are going to use, and this is the proof, and this is the knowledge used. So if you are interested in this part, you can read through and try to digest. So let's set this. Assume m and n are positive integers. So here I restrict the range to be positive just for convenience. So and m less than or equal to n. So this is not essential because we can switch m and n if needed, right? We can always assume m is less than or equal to n just to fix the idea. And then we do division with remainder. So let's call qr equals, let me use this. Qr equals the division of n by m, so q is a quotient, r is the remainder. Then the GCD of the original two numbers, m and n, equals the GCD of m, the smaller one, and the remainder, right? The remainder is smaller than m, right? Because due to the definition. So this way, actually, we can write a recursive function to compute GCD. So with that said, I guess we are ready to do the coding. So for the coding, so first I'm going to write a very simple version. So actually we can write this by one line, but that's not our purpose. Let's first get m and n. So let's see, little m is the mean element, and capital M is the maximum, right? So what we are going to do is to return the GCD, right? So we can call this GCD method in this math library or class. So then we can put m and m, right? So this is one way. So we can check, right? So we can directly submit that. So that's it. So here, this is not our purpose of using this this function. So what we are going to do is to write a hyperfunction to compute the GCD. So because that function will be of independent interest. So let me comment this out. So here I'm going to write a GCD function, right? GCD for given m and n. So here I'm going to assume, so I'm going to write with some generality. So I'm going to assume m and n are integers. So it can be negative, right? Also can be 0, right? So but we return the positive one, the positive GCD. So in other words, if this is actually some sort of convention. So if d is a GCD of two integers, then negative d is also 1, right? You can divide it if you consider negative coefficients. Here, let's emphasize our assumption. So here m and n are integers. There can be 0, can be negative, can be positive. So what we are going to return is the positive GCD. In other words, we are going to reduce to the case both m and n are positive. So this is the plan. So next, we are going to do the actual coding. First, we are going to consider the case if m equals 0. In this case, so n is the GCD of the two numbers. So we are going to return n. So similarly, if n equals 0, so we are going to return m. So the first two if checks consider the case one of m and n are is 0 or both of them are 0, right? So after this two if, both m and n are non-zero. So actually we can do the following: abs_m, abs_m. So because our return is positive, right? So this is the one consideration. So next we want to do some reduction. So we can assume m less than or equal to n. If not, so if m is greater than n, so we just need to switch, right? So this way we always have m is the smaller one, or at most so m equals n. So then what we're going to do is check if n modulo m equals 0. In this case, m is a factor of n for sure. M will be the GCD, so we're going to return m. Otherwise, we're going to use division with remainder. So div mode. So n divided by m. So m is the divisor. So in this case, we're going to use recursion. We're going to return. So we can do self-call GCD, right? So we want to return m and r, GCD of m and r, due to the first item we mentioned. So this is the knowledge we used. So with that said, so actually we finished the implementation of the GCD function. So you can try several of them, right? Let's see, GCD 0 and 3. So this should return 3. And GCD, not GDC, GCD. So actually these two are commutative, these two functions, so it does not matter. So now let's see, GCD 12 and 24, it will return 12, right? GCD of 3 and 2, we are going to return 1. So also I can do return GCD of little m and capital M to test if it's right or not. So let's first do a special case check. It's right? So let's print out these things. Print. So let's also put one so that has negative things. So actually due to our treatment, this does not matter. So let's do this. So we have 3, 3, 12, 1, and 1, right? We are going to get 2 for this problem for first test case. Let's comment this out and test all the cases. Yeah, it passes all the cases. So with that said, I guess that's about it for this specific problem, which is actually an easy one. So with that said, that's it for this video. Thank you.